Section 5.7, Square Roots and the Pythagorean Theorem. In this section, we'll be looking at how to calculate square roots and understand the concept of a square root, and then we'll also look at how to understand and use the Pythagorean Theorem. Before we begin looking at any examples, let's start with some terminology that we're going to be using as we discuss radicals. First of all, the symbol here is called a radical sign. It is not only used for square roots but different kinds of radicals, but we're going to be focusing on just square roots for now. The number under the radical is called the radicand. So if you had something like the square root of 49, in that case the 49 is the radicand. And the complete expression, the square root of 49, is called a radical or a radical expression. So the symbol is a radical sign. The number under the radical sign is the radicand. And the entire thing is called a radical or a radical expression. Now, let's try to compute these square roots, and let's try not to use a calculator, although we will talk in class about how you can use a calculator to compute the square roots. So when I'm doing 15 squared, what I want to know is what is 15 times 15. So either you can know that from memory, which is 225, or you may have to take time to actually do the long multiplication and get that same answer of 225. 11 squared, remember, is 11 times 11, and that's 121. When I ask the square root of 256, I'm looking for what number times itself would give you 256. Well, that would be 16. And then the square root of 81 is what number times itself would give you 81, and that's 9. So the square root of 81 is 9. The square root of 256 is 16. The Pythagorean theorem is actually a really neat application to radicals. So what the Pythagorean theorem says is if you have a right triangle, and that's really important, it has to have a triangle with a right angle or 90-degree angle. The square of the length of the hypotenuse, which is always the side opposite of the 90, and it's also the longest side in the triangle, is equal to the sum of the squares of the two legs. So we normally see that written as c squared equals a squared plus b squared. You might want to remember it as this: leg squared plus leg squared equals hypotenuse squared. So that way it won't matter what variables they give you. In case you don't have a, b, and c, you'll always know that you do leg squared plus leg squared to get the hypotenuse squared. In example 2, they want me to show that if I have a triangle with sides of length 3, 4, and 5, it has to be a right triangle. Well, from the Pythagorean theorem, we know that if this is a right triangle, then the statement that a squared plus b squared has to equal c squared has to be true if we let c be the hypotenuse, and then the 3 or the 4 can be either a or b. So I'm going to let a be 3 and let b be 4. So then, can I show that 3 squared plus 4 squared equals 5 squared? And we do get that 25 equals 25, which is true. Therefore, you must have a right triangle. In this example, we're going to be trying to find the length of the hypotenuse if our legs are given to us. So let's sketch a picture. So we know that our legs are 5 and 12, and we want to know the hypotenuse. So we'll use Pythagorean theorem that says a squared plus b squared equals c squared. And again, it doesn't matter which one is a or b. So I'm going to do 5 squared plus 12 squared equals c squared. But that's 25 plus 144. But that's 169. And if I have c squared, I need to take the square root to get c. And 13 squared is 169. So C has to be 13. In example 4, we are going to find the length of the hypotenuse if both of the legs have a length of 1. So, again, using a squared plus b squared equals c squared, we would do 1 squared plus 1 squared equals c squared. But that's 1 plus 1, which is 2. And then to get c, instead of c squared, I take the square root. And the square root of 2 is irrational. That means that it doesn't repeat and it doesn't stop. So if we want the exact answer, it's the square root of 2, or we can use a calculator and approximate it to be 1.41. Now let's apply the Pythagorean theorem to a word problem. We have a guy wire that's attached to the top of a telephone pole and anchored to the ground 10 feet from the base of the pole. The pole is 20 feet high and we want to know what's the length of the guy wire. So we'll call this C. So looking here, we can now make a right triangle out of this, and we can do a squared plus b squared equals c squared. Since c is my hypotenuse, I can do 20 squared plus 10 squared equals c squared. But that's 400 plus 100. So 500 equals c squared, and we'll take our square root. And now I need the square root of 500. And we find out that that's 22.36. Let's put our units on this. We were measuring in feet, so C has to be 22.36 feet. At this time, I would like for you to turn to page 207 in your book and work on problems 7 through 12. We will check the answers when we get in class next time, and I will answer any questions you have about either the video or the problems.